Hey, so welcome back from coffee. This is the final session for today for this year's VETS conference. We have Don Syme here from GitHub, formerly GitHub, I guess. Well, still currently GitHub, but now Microsoft, right?
Oh, GitHub got acquired by Microsoft a long time ago, but GitHub operates pretty independently.
Okay. Right.
As far as I'm concerned, I'm a GitHub employee. Okay, I am no longer Microsoft. And he's laughing here. He knows just what I mean.
But yes, the repositories we use and love, Don is somehow responsible for all of that.
Yeah, the outages, use and love. Yeah, fantastic. Okay, well, this is probably the least formal talk in many ways, though I do try and make it formal at the end, not because just by accident in a way that I ended up at. So I used to be a formal guy back in my PhD and before my PhD, but then got into programming languages and then found myself over at a wonderful group called GitHub Next, which sort of has its origins in the people who started using LLMs for code completions in what became GitHub Copilot. Microsoft then took the brand Copilot and used it for like 70, 80 different things. But GitHub Copilot was sort of the original kind of breakthrough in the use of LLMs for code in the industry. And so some of the people worked on Copilot. Some of those people have then moved on to other things too. But it's kind of got that origins in AI for code. And obviously, because we're at GitHub, that kind of poses a very broad range of questions. Like, right from the start of when I was with this team, we were immediately throwing around, ideas about AI for code review or AI for summarizing code or AI for generating tests or whatever. So this is an endless... very rapid. We've sort of been at the center of things, but also off to the side of what GitHub do. We're an innovation team. Our mission is, it's a little bit like kind of Microsoft Research, but it was kind of up close to GitHub as a product. Smaller team, a more mixed set of capabilities rather than being siloized into like formal people in one group and then sort of UX, user experience people in another. We're a bit tighter together with an interesting mix of skills. So wizards, we're all wizards these days. It's quite disturbing to be sitting. It's quite disturbing to be working as an industrial researcher in an industrial research lab because you might come up with ideas and the next day the product teams have said, oh, thanks very much for the idea, we've gone and implemented that, we've stripped your ideas and it's all implemented straight away, because the cost of implementation is just falling so rapidly and it makes everybody a magician. In fact, when you're sitting in a room and having a meeting or on a call, everybody's a magician. It's kind of like the Magic Council in Lord of the Rings. Imagine them just all wizards, all sitting around. They can all just bang the staff and magic up whole implementations of things. And people are suffering this in boardrooms. They have their CEOs kind of vibe coding something up in the evening, an idea, and then demanding to ship it the next day. It's strange times. I use this slide for for undergraduates at KCL. Just to say things can also blow up. This is Gandalf as a younger Gandalf in Rings of Power. Things are blowing up on him as he learns to channel the power. And we use that terminology. I'll be using it later on in terms of guardrails for automated AI. You've got to channel the automated AI, guardrail it. So the language is not that far off. Okay, so what we're cooking up at GitHub Next is it's really just like a change of modality in how we do engineering. We've observed the Copilot thing and all the kind of ChatGPT, and I guess it fits in what we'd call the individual productivity tooling. It's all about making the individual information worker more productive in what they're doing. And the problem is it's all human initiated. It's all individual. It's not team based. It's not particularly contextualized. We've got to bring all the context in. And so there's I don't think that's what people actually want. So we did a sort of more conceptual, it's almost just a language project, really. It's just introducing a term to the industry. And it's a deliberately constructed term because it's a term for which GitHub can be the answer to this question the term poses. Okay, so we're all very aware that, there's this huge part of the software industry centered around DevOps or continuous integration and deployment. We usually just use CI/CD without really thinking about what those words are. But, what does continuous in the context of GitHub means? It's a changing platform where the repository is a place of change and activity and collaboration, and things are always happening, and you're always reestablishing these invariants at every kind of step. Everything is deployed. There's there's like a machine, a factory that's kind of progressing as change happens in the software repository. Now the question is, can AI play in that space? And in some sense, the answer is obvious. It can, but it's just quite a large mental shift. First of all, if you go talk to DevOps people and talk about bringing AI into their DevOps, they'll kill you, right? First of all, if you say you're going to get rid of CI/CD and replace it with something non-deterministic, they're going to freak out. So you've got to be very careful how you talk in this kind of space, because there are one way of putting it is CI/CD is where the grown-ups are. Okay, CI/CD is where things actually really get checked before they're deployed. Like in the code, when the individual developer on their machine installs all these crazy tools and does all this crazy stuff, but CI/CD, that's if you break down an enterprise between the devs doing all the crazy stuff, then the CI/CD is where things get serious, get real, have to be, and that also makes that's where things get deployed from. For example, that makes them a huge attack. They're a vector for attack for say package deployment. You actually see those attacks quite regularly, including on GitHub. So bringing AI into this kind of space is not automatic. But on the other hand, once you have the term continuous AI in your head, you kind of start seeing it everywhere in what people are trying to do. They want to continuously document their code. Like why, that's an entirely reasonable thing. It's almost a very obvious thing to want to do with AI. Or you want to continuously improve your code. That's slightly less obvious that you want, say, code comments, or maybe you want your code to be more strongly typed, maybe get rid of the uses of any types, maybe you want it to be more performant. There's lots and lots of ways the code can be improved sort of on an ongoing basis. Then there's all the metadata, project management kind of thing. You might want to triage or summarize issues, respond to issues. You might want to reproduce them. You may want to augment them with more information. Fault analysis. So first of all, the repository can start to fail. The automations can start to fail, and you can have other automations start to kick in and kind of check why CI is failing or something. But you can also have ones that deployments fail. The website fails. You start getting 404s or 401s or whatever on the website. They get logged on the server side. An automated process can kick in and automatically assess what's going on, collect all the information, and have an analysis ready in 5 or 10 minutes automatically for the engineer to pick up and fix that in the website. So that continuous fault analysis is a really big and important engineering job, part of the factory of the modern software situation. Continuous quality, it's related to improvement. And then there's the soft stuff, kind of motivation, summaries. And then there's the stuff that's orthogonal to the main team: continuous security, compliance, continuous accessibility. And what that would mean is that every day you've got a fresh, available a kind of compliance report for the code. Compliance is not something you do once at the end of the project. It's a continuous, ongoing thing that you do. Or fixing up the accessibility of your website is something that is done a continuous engineering process. And okay, so you get the idea: automatable, repetitive, collaborative, integrated, auditable. There's lots and lots of variants of this kind of thing. So this is all posing a question. And a lot of this some of this is true for continuous integration and continuous deployment. And for a lot of the industry, the answer to the question of continuous integration and deployment is GitHub Actions. There are plenty of other systems as well, but it's quite natural for GitHub to seek to be the answer to the continuous AI question. And that's really a question, terminology we were bringing to the industry and a question we were bringing to the management to get them thinking about being the answer to that question. And in a way, I think it is inviting GitHub to its actual destiny in the world of LLMs and AI, in the AI era. GitHub is obviously a platform that was created in the human-to-human interaction era. It's challenged by the AI era, and we need to think about what is our natural place in that world. Okay, so that's just that term. Of course, we want an actual implementation of this. You'll see many implementations and many examples of continuous AI over the coming years. There are already other implementations and examples. Google people have a system called Jules, for example, from Google Labs that is all about automation with automated AI. You can see elements of this in things like OpenClaw. So we built a thing called GitHub Agentic Workflows. This, you can see the messaging around it. The idea is it's just like a GitHub action, except it's agentic. Instead of checking in a YAML file for some automation, you check in a Markdown file. And you just check it in, some stuff starts happening. AI, all of that stuff we just saw, all of it. Just write some Markdown and bang, you're off and running. So what does it actually look like so concretely? I'll give you an example here. No, I've got an example in my slides. Okay, so yeah, the high level, you're actually running coding agents. You don't really know it. You don't really see the coding agents. You're running, that it means Claude Code or Copilot CLI or Gemini CLI or Codex or whatever. And they're running them in an automated, sort of triggered, scheduled or kind of way. We care a lot about security, so we add additional sandboxes and additional strong guardrails, and we run on GitHub Actions, but with sort of a compilation process or a hardening process. So let's look at an actual workflow. It's got some front matter, it's got some triggers, it's got some triggers, and unlike a normal GitHub action would say, you can get the permission to write to all the issues in the repository. So we're much more guardrailed than that. So we give a much tighter kind of safe output. This is allowed to create one issue. It's not allowed to delete issues. It's not allowed to modify existing issues. It's not allowed to add comments to existing issues. All it is one issue. That means you can sleep well at night. But this thing is at most going to, the blast radius of this thing, even if it got hijacked in some sense, is very small. And that actually really matters. There's one thing that's weird about automation is that in individual developer productivity, constraining people is not appreciated. Everybody just goes YOLO, 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 just like let it do whatever it wants, right? Because they want to be more productive. In automation, it's the other way around, which is that it's like a train tracks. The better the train tracks, the stronger the guardrails, the faster you can go with ease and with confidence. And so that's very, so once you constrain the action of these things down enough, you can create lots and lots of them and let them run without worry. I'm not saying things can't go wrong, but the guardrails have to be tight. Okay, so it's got some sort of tools. It's got some kind of natural language programming. The markdown below is probably very deliberately ambiguous or genuinely useful ambiguity in the style of natural language programming, allowing the models enough space to do all sorts of interesting things. It might just say, pick an issue and reproduce it and try to reproduce it and write up your notes from your reproduction or something very general like that. And it's actions familiar, so the DevOps people will all be happy with this once they get used to the idea. It assumes it's running on GitHub and it's sort of usually self-reporting in some kind of way. It might be triggered slightly differently, triggered on every issue opening or something. There are cost issues associated with that. You might choose to do things in batch mode instead. And this might, do an issue triage of some kind. And we make it super simple to get going. So you want to add an automated process to do test improvement. And what that means is that each morning you will wake up to a pull request, which improves the tests in your repository. That workflow might have done a coverage analysis. It might have compiled your code and run your tests and done the coverage and read the coverage report and decided found some gaps in your test coverage and decided, actually, we're going to add some more tests here. It might be adopting a new kind of testing. It might be introducing property-based testing into your code, but you don't care really, because it's just like you've effectively hired an employee, a virtual employee of a kind, to go and look after improving the tests in your repo. This will ask you for a key to an LLM, so an Anthropic key or a Copilot token, and take you through that process. But it's pretty simple. Now, what does it actually add? I mean, it's just a GitHub Agentic workflow. So if you look, for instance, if I just go to, say, one of the F# repos here, we're talking about this repo later, and I come to GitHub workflows, there's the standard CI/CD here, and there's just some continuous AI next to it. So this is the workflow I added. Now this is the markdown. And the lock.yaml is the hardening of that, where we apply a security architecture around that, where we invoke the coding agent, but we do it inside a container, and we put the guardrails on the thing. So you can kind of think of this as not really a compilation, because we still use the prompt, but it's more the hardening of the workflow into a thing that actually runs. And then otherwise it's just like actions like you're used to. And so there's it running and there's it failing. You can see it's the menu kind of runs its head down below. You can kind of dig into those here. And you can look at the agentic reasoning. It was digging into some Windows CI failure, which I had asked, I don't know, and it kind of worked something out, and then you can kind of see various other things done, and the safe outputs that it actually created. It created a pull request and it added a comment. Okay. So agentic automation, safety, guardrails really matter. Just, you've probably got the idea already. Sandboxing, minimize permissions. The agentic step itself runs read only. Like, it has no write permissions to the world apart from its safe output. And that's such a strong property. Most of the systems in the world are using MCPs, giving them write access, giving them tokens. It actually runs without access to any tokens at all, because we use, so even read permissions are done via a gateway. And I've talked about the guardrails and firewalls. Okay. So, and there's a write-up on the security architecture. It's a lot like, a lot of people we talk to in companies, say you go to a bank or something, and they've been trying this sort of stuff, and they've been coming up with these kind of security architectures, and they're really glad to throw their security architecture away and say, actually, GitHub will use your one. But it's pretty much in the zone of what a lot of people have been doing. So once you have GitHub Agentic workflows, what I've really liked about this project is we've been investigating a lot of the ramifications of this for software engineering and how we do everything in software. And one approach you can take is what I call the agent zoo. And to give you an example of what I mean by this, if we go to our own repo, if it works forwards here, and we look at the workflows we have hundreds and hundreds of these things just to run through. We've got an AI moderator, we've got an architectural diagram generator, we've got an architecture guardian. I don't even know what that does, but we've got something that audits the other workflows. We've got something that auto triages, and we're only up to blog auditor. And we've written this up. It's called Pelly's Agent Factory. We made it fun because we've got Pelly DeHalio from Microsoft Research, who's my main collaborator with this, and Mara as well. And we kind of, let's take the philosophy of let's create a new automated agentic workflow for just about everything. So we're just going to max out on that. And where does that kind of lead you? So kind of a candy shop chocolate factory of agentic workflows. So there's some themes here which I'm really happy with, and they kind of match some of those themes earlier, but they're a bit more computer science and they've got a bit more evidence about it. So let's take I'll dig into continuous code improvement. There's so this first one, for example, says if you already have dependencies, if you're already using certain Go modules, why not make better use of them? Why not try to kind of improve? There are probably things in there you should be using that you don't know about, and maybe we can improve the code by, like, if you've already got the dependency, you may as well use them. This one says, let's try and make code more type safe. This one says, let's try and use functional programming tastefully, which is pretty hard in Go's miserable functional programming. This one sort of just does a general holistic kind of let's improve. And in these things, there are actual examples where you say, actually, let's take a look at what that did. You can click through and say, this created this discussion. Pelly did this, created the parent issue, and various actual things were implemented. And you can kind of see the causal chains for the human agent interaction in the overall process. And there are some statistics too. Okay, so Pelly's Agent Factory. Another thing you can do is sort of more targeted workflows like continuous test improvement or continuous perf engineering. I spoke at that at the last workshop. And I just want to talk about two things. One is continuous repository maintenance, and one is continuous formal verification. And I will talk about continuous repository maintenance. So it's mainly written up in this blog, which is, I would invite you to go and read. It's just an example workflow called VeTSS, which I've used in repositories, fairly dormant repositories that I have been responsible for. And it's great. And I'll show you it's great by showing you some graphs. I try and guess why I started to use VeTSS in this graph. This was a number of bugs in this repository over time. It was just dormant, flat as a mouse. Nothing was happening in this repo, partly because they're just like bugs, right? Nobody was looking after it. I wasn't looking after it. I meant to be. And then I installed VeTSS. I did force run it because it was doing good things. So I kind of dialed up the automation. So yeah, this is great. And then I started actioning the issues and actioning the pull requests. And then over the course of like 5-6 days, just completely crunched out the technical debt. So you take a piece of software that's installed millions of times, and you just effectively it's using the coding agents to crunch out the bugs and then put it into a mode where, this thing now only runs once every 3 days or something. And it's just, you're just in a good state for this repository kind of going forward. So crunching out the technical debt, it works with other repositories. Here's a whole group of them over time. Not all of them follow the same trajectory. The two I showed you are kind of on that list somewhere, the most extreme ones. Some repositories didn't kind of have that same kind of effect. So I was working on this report. Let me just show you the report. Here's the docs on VeTSS. Here's the report I've been writing, Impact of Automated Repository Maintenance Assistance. So there's that graph. One thing, once you have this, you can kind of look at the repository as a factory. And you can use traditional factory kind of sort of systems thinking for how much velocity have we got through this factory, or are there bottlenecks in this factory? You kind of, now these were nearly all dormant repositories. You can kind of see the kind of velocity you had down the left here, and then the velocity that we achieved by using repo assist here, whether issue closure velocity or PR merge velocity. I talk about social factors involved. You can kind of come up with a process flow model for the repository. And then you can kind of assess repositories as if they're a factory, right? So this first 4 of these ones are all actually kind of blocked because, well, for reasons like but basically the underlying reason is the automated part of the factory was overwhelming the human part of the factory, and the human turned it off, or turned it off for a while. In some cases, they've said, "Yeah, I'll turn it back on again. It's really good, but I only do this every month or 2 for this bit of software." Some of the factories are flowing, and some of them are kind of in idle because there's no more bugs to fix. There's no more input into the factory. Okay, and then this is sort of other views on that same data, and then per repository kind of views on that. Okay, so that, yes, so kind of this, the repository as an automated software factory. This is, we're all going to be factory designers. Collaboration is about collaborating in the context of a factory. It's the new world, and it's kind of fun, to be honest, especially when it's all kind of integrated like this, and you're getting lots of incredible software done. But certainly you can do a lot more than you did before. So I talked briefly about one other thing, which is much more formal, which is Lean Squad, and that's written up in a similar blog post with the provocative title of sort of what I think. I'm actually not a big believer in formal verification, right? I actually say it in the blog post. I kind of say it's just too labor intensive. It's just too expensive. Yeah, there are some places in the industry where you might use it because you've got a hypervisor or something like that, but it's just insanely expensive, and no one in their right mind is going to do that twice, right? Once you do it to a bit of software once, you're going to do another hypervisor all over again with the kind of same labor and the rewards, the incentives aren't there to do that. And I've seen that at Intel when I was working there on formal verification of chips. It's just really hard to make it actually work at the human level. But what about if we have near zero human labor? But that requires making some really big trade-offs, which really go to the heart of what are we actually doing here? And is it actually worthwhile? Because that really means we have to probably get the models to do everything. So I'm looking it's about exploring a form factor or a kind of packaging of formal verification. A bit like that test improver. In this setting, you're just going to run 2 lines, these 2 lines, effectively just that line, and it's like hiring a squad of formal verification experts, locking them in a room, giving them the food they need, and asking them and telling them to not bother you until they found something interesting, right? That, I think, is how this stuff eventually will be delivered. So Lean Squad is a sample of that. This is the things it does. And I'll show you a couple of examples of it in practice. So this is an implementation of the Raft distributed consensus protocol, about 52 Rust files. But the point is, I actually don't know what it is, really. And you just check in the workflow, and a few days later, the formal verification work has been done. Now, you're quite welcome to criticize whether this has been done or not. In fact, if it's not been done, we should find out what's gone wrong and why it hasn't been done, right? I want people to say, actually, this can be made better in some way. And it produces a report, and it says it's proved unconditional end-to-end Raft cluster safety, full protocol. It's proved 716 theorems, and it's showing you the whole proof architecture, and you can zoom in on this thing here and kind of look at everything that's been done. As it's gone through the safety thing all the way down here to the final full protocol step, kind of safe. Clearly, it's read the underlying thesis on proving the Raft protocol safe. It clearly knows a lot about this. It's probably read whole entire automated proofs on this, but it's never applied them to this code base. And now there is a correspondence argument it makes on the implementation model between the Rust code and the Lean that it's using. That's using some abstractions, and it documents what that correspondence is. Here, for example, it says this is an exact correspondence, it's an abstraction, and it says why it's using recursion, not this. Okay, and I'll finish up. Yeah. So yes, Lean Squad. One thing I love about Lean Squad is that it can be applied to whatever software you like. And it's kind of like scratching that itch about what would it actually, I don't know what it would mean to apply Lean to drone software, for example, PX4 Autopilot. So why not just check it in and kind of see? And so you can explore what it would mean. And you can look at this as kind of a first approximation of what formal verification would mean. You can read the research report about what it's done, about what, you can read the final report here about what it's done. And it's, it's verified braking distance safety. It's verified at the atmosphere, ISA atmosphere model. And, is it useful? I don't know. It did find some bugs in this case. It found one bug. Here's probably the most interesting one. This sign function, turns out it can return 0. It says no 0, but it can return 0 if the input is nan. And it found some call sites that were affected by that, and it found the risk if something became nan. And those actually sound kind of serious if this is a expensive bit of kit you're flying. Orbit radius becomes 0, or a loop never terminates because this is actually 0 here. That's probably worth fixing. But it's a lot of tokens got burnt to find one bug. And there's probably better ways of finding that bug. But anyway, that is all, I think. Lean Squad. So the repository is an automated formal verification factory, ? For this community. And that's all. Thanks.
We have time for a question. Anyone has one?
Sorry, you said you would like people to challenge you and say...
Absolutely, yeah.
Okay, so
I'm not even making any real claims about it, yeah.
Have you yourself looked into what it has proved and whether or not you agree with them? And if not you, then who?
So that's documented in the blog post. So in the case of the Raft protocol, so you can do nudges to the thing, and it documents the 3 nudges I made to it. And the nudges have big effect, right? They're like a big booming voice to the model in its future kind of direction of work. And my first nudge was kind of saying, look, just get to the end picture. I want to see, what are you trying to do in the end? And so it did that. But it did that by making a whole lot of assumptions about this final thing. And I hadn't realized that until I was writing the blog post. And so then, I effectively acting as auditor, and I realized there's a whole lot of assumptions that have never been discharged. And then I went back and I said, actually, could you discharge those assumptions? And it said, oh, yeah, I've got a whole lot more work to do. Okay, so yeah, clearly there has to be an auditing process. This stuff is obviously going to be more effective just like if you hire someone to do a job for you, if you don't know anything about what they're going to do, they're going to rip you off, right?
Indeed.
And they're going to steal your tokens and go away, right? And that's the same thing here. The person governing the work or commissioning the work or negotiating it and assessing the work has to know enough to get the value from the work. Mm-hmm. Okay, so I don't believe it's a zero human labor thing. I don't believe it's like something but it does change the role of the human very much, change of the commissioner for the formal verification work. And surely the big thing is what are we actually trying to prove here, given this category of software? What are the things that are in the right zone between not too obvious for testing and not so impossible that they could never be done? And there's also the process of making sure it's grounded in the model through either using Aeneas or some kind of automated tool chain. If you can cut out that correspondence step and automate that to really get it grounded down there and get the tools operating over, bit vectors instead of natural numbers and things like that, then yeah, I think the community are working on, this came from chatting with Cedric at Microsoft Research, Cedric Fournet, and it's clear you're working on the right pieces. Perhaps part of the message here is that the end packaging of all the tools you're building, the end user of most tools in this kind of setting will be an AI model. It won't be a human manually. The labor to use the tools won't really be provided by humans. It will be AI models governed by humans, which is just a big change in perspective. There's a lot to digest and unpack about what that really means and the ramifications of that.
Thank you so much for the great talk. So maybe I've missed something, but in the second example that involved formal verification, you had some sort of float computation going on. And I was wondering, how did you verify that with Lean? Did you use some external library? Because the native Lean float implementation is really a wrapper around the hardware type, which you cannot really prove things about because it is opaque. So I was wondering, did you use some specialized
for this to do with this
yes
this code here? So I think the model it added an issue for this bug. I don't think it was proven with respect to IEEE. It found the bug, but if you look at its analysis, it was actually using rational numbers. Okay, but it kind of found the bug, but not through proof. So effectively found it through code review.
Mm-hmm.
Again, I've got big questions over how many bugs are there to find that couldn't be found by throwing the tokens at code review and other automated testing, property-based testing kind of processes. So there is still a big question whether the formal side of this is actually valuable. And I'm neutral on that because, it's like I'm no longer a kind of a believer in that sense. Like I'm not doing it for the formal kind of thing. I'm just doing it to investigate the use of automation with Lean as a particular tool. I should say there's another grand challenge lurking here, which is to not make this specific to Lean. The AI models can do all your tools. Okay, they can use bounded model checking, or they can use Lean, they can use whatever. So if you can change Lean squad to just be FV squad or just V squad, the verification or validation squad, who actually use the right mix of tools for the right software, given the point in the repository and given the goals that the repository has, and then and it can get all the tools out of the bag. It can do everything, and that's something humans will never be able to do because it's so hard to use some of these tools well. You can only usually use 1, 2, or 3 of these tools, right? Models can use all of them, especially if prompted well. So so that's if you're looking for a grand challenge, the multi-tool, multi-kit Swiss Army knife automated V squad is within reach. I think. Yeah.
Thank you so much.
Yes, Sophia.
At the beginning of the talk, you showed us some very impressive graphs on what happens to code repository when they start using this. I don't remember what the tool is called.
Yeah, RepoSys. So an automated repository bug fixer.
So I've got 2 questions. One, you have got this number of bugs falling. Were those bugs known in advance, or did the tool find them and then found that it existed in the past also?
No. So these graphs, the bugs were known and were part of a backlog that weren't being addressed. So the repositories were in sort of dormant mode with bugs attached.
So I'm getting to the next question. What you have shown us is the tool being applied to code developed by people. Are there any studies where it has been applied to code developed by AI?
I mean, first of all, I wouldn't say this is a full study, partly because I was a maintainer on some of these repositories. And so this is not proof that, not all of them, but clearly I think the stalling rate is higher for people who aren't me. I've got a big motivation to actually use this tool. So in some ways, it's a proof that individuals can now make automation which is suitable for them and some of their community. There's a big social factor in whether people will be happy with this kind of automation. Some people hate the use. There's also an intrusion on the human-to-human collaboration process in these repositories. Now, with regard to AI, we use that ourselves. So part of the use of automation is to clean up the AI slop that the models create. So there's 2 ways to deal with AI slop. One is to kind of make it, review it really intensely and put it through lots of kind of quality gates to kind of crunch it down as it comes into the repository. The other is to use a more eventual quality kind of model, where you let the slop come in and you have a cleanup army running behind you to clean up or to put the code into a good shape that you want. I use the example of long files, for example. So the AI might create really big files. That's not really a problem for correctness, but you might want a cleanup agent that runs along behind you and kind of cleans that up and reorganizes the code and makes it all really nice. So we use AI automation all the time on AI generated code. Nearly everything we do is AI. Like most developers now, it's all AI generated code, guided code.
That's really great. Thank you. I think this discussion could go on for a lot longer, but you've given us a lot to think about.
Okay,
Thank you.
Thanks.